was built, always undivided. Love is the key. In unity, let's share His love with another. We are one. We are one bread, one body, one people. United we stand, divided we fall. If we put our trust in the Lord, there'll be melody, love and harmony in every heart. Teach us to pray, Lord, every day. Show us the way, help us feel your loving kindness. Love is the key. In unity, let's share His love with another. We are one. We are one bread, one body, one people. United we stand, divided we fall. If we put our trust in the Lord, there'll be melody, love and harmony in every heart.
All right. All right. So with that, we are now motivated. And to further continue, just for the information of everybody, all the activities for today are in accordance with the IATF standards. So to continue our celebration, will be a welcome remarks from no other than our Administrator for PAGASA, Dr. Vicente B. Malano. And for the information of everybody, Dr. Malano is also our permanent representative to the World Meteorological Organization, which is a specialized body of the United Nations. So may I call on stage Dr. Vicente Malano, sir?
USEC Rene Solidum, USEC for Scientific and Technical Services of the DOST, Dr. Michael McFadden, Senior Scientist, Pacific Marine Environment Laboratory of NOAA, USA, Dr. Wasila Manadu Tiao, Team Lead, International Desk, National Center for Environmental Prediction, Climate Prediction Center of NOAA, Dr. Yong Okwon, Senior Scientist, Physical Oceanography Department, Woods Hole Oceanographic Institution of the United States of America. Esteemed scientists from different meteorological agencies, partners, stakeholders, and dear colleagues, ladies and gentlemen, good morning and welcome to this forum, Linking Philippine Climate and Weather with Tropical Oceans. On behalf of PAGASA, I would like to express my deepest appreciation to our distinguished guest speakers. Thank you for gracing our scientific forum in celebration of the 156th National and 71st World Meteorological Day, anchored on the World's Meteorological Organization's theme, the ocean, our climate, and weather. I would like also to acknowledge the hard work of the men and women behind the celebration. Thank you for making this virtual forum possible. Today, March 23, is the World Meteorological Day, in which we coincided it with the founding anniversary of the Philippine Meteorological Service. This celebration acknowledges the essential contribution of every national meteorological and hydrological service in the world in enhancing and strengthening PAGASA's own Met services to help reduce risk and keep lives and properties and as well as livelihoods safe during weather and climate-related extreme events. Today's forum highlights the role of the oceans in affecting world weather and climate. Advancements in technologies to systematically monitor the oceans would also be discussed. We'd also learn about the latest tourist models, observations, and challenges of forecasting El Niño Southern Oscillation and climate variability. We hope that this forum would bring light and understanding on how nature and science work and how we humans could respond accordingly and efficiently. Thank you and welcome to this forum. God bless us all.
Thank you very much, sir, for that very warm welcome remarks. And to give us more, let's hear it from the Undersecretary for Scientific and Technical Services of the Department of Science and Technology. He is also the officer in charge of the Philippine Institute of Volcanology and Seismology, or PHIVOLCS. Let us all welcome Dr. Renato Solidum. May we put Dr. Solidum online, please? Wala siyang audio. Nakamute yata siya.
International Desk of the National Center for Environmental
Ako magsalita.
Climate Prediction Center of NOAA.
Sir, could you please unmute your phone, please? Your microphone. Sir, you're muted. We can't hear you.
Our colleague from PAGASA, Mr. Juanito Galang, officer in charge of the
Thank you very much, sir, for that very inspiring message. Since today marks the 71st World Meteorological Day, World Meteorological Organization also have a message for us and will be delivered by Professor Petteri Taalas, the Secretary General for World Meteorological Organization, via online from Geneva, Switzerland. And this will also be followed by Dr. Wasila Tiao from the National Center for Environmental Prediction of the NOAA.
Greetings from Geneva, from WMO. We are today celebrating the World Meteorological Day of 21, and this is to commemorate the signing of the basic agreement behind the WMO 71 years ago. Actually, we are a much older organization. We were established already in 1873 as International Meteorological Organization, and we are the second oldest United Nations organization from that perspective. This year, the theme of World Meteorological Day is devoted to the theme, the ocean, our climate and weather. It celebrates WMO's focus in connecting the ocean, climate and weather within the Earth system. The WMO community has a major stake in supporting research, observations, predictions and services and closing data gaps for the ocean. Our changing climate is warming the oceans, having a profound effect on our weather. 2020 was one of the 3 warmest years on record, despite of fairly strong La Niña cooling in the Pacific Ocean. Last decade, 2011 to 2020, was the warmest decade on record since 1850s. Ocean heat is at record levels, ocean acidification is continuing, sea ice is melting, the rate of sea level rise has accelerated during the last decades. In 2020, the annual Arctic sea ice minimum was among the lowest on record. Polar communities suffered abnormal coastal flooding and sea ice hazards as a result of melting ice. Warm ocean temperatures helped fuel a record Atlantic hurricane season and intense tropical cyclones in the Indian Ocean and South Pacific Oceans. Actually, in the Atlantic, we were breaking the record in the amount of hurricanes. With more than 40% of the global population living within 100 kilometers of the coast, there is an urgent need to protect the communities from the impacts of storm surge and coastal hazards through improved multi-hazard early warning systems. Nearly 90% of the world trade is carried across the sea and is exposed to the dangers of extreme maritime weather. WMO partners with the International Maritime Organization and the International Hydrographic Organization to provide standardized information, forecasts and warnings to ensure the safety of life and property at sea. WMO works very closely with UNESCO's Intergovernmental Oceanographic Commission for Ocean Observations and Research. WMO is proud to contribute to the UN Decade of Ocean Science for Sustainable Development 2021-2030. WMO is committed to the safe ocean, predictive ocean and transparent ocean goals of the decade. To understand our weather and climate, we must understand our oceans. We will continue working towards this to protect vulnerable communities and in support of the Sendai Framework for Disaster Risk Reduction, the United Nations Sustainable Development Goals and the Paris Climate Change Agreement, as well as Samoa Pathway. WMO is leading several important global initiatives during the coming years to address priorities of our members. The importance of enhancing global basic observing network and putting in place innovative financing facility, SOF, to ensure systematic weather and climate observations, especially for LDC countries and SIDS. Secondly, we are creating a water climate coalition for accelerating action on Sustainable Development Goal 6, which is related to water. And thirdly, we would like to ensure enhanced multi-hazard early warning systems and services at all of our member countries. And we are working hard to get external resources floating for these purposes, and we are already assisting record amount of our members with those resources. With these words, I would like to wish you all a happy World Meteorological Day, despite of these unusual times that we are having worldwide. Thank you.
Good morning. My name is Wasila Chow. I work for NOAA's Climate Prediction Center. I am the director of the international desks. I would like to thank you first for inviting me to this ceremony. It is a real pleasure for me to join PAGASA in the celebration of the World Meteorological Day, 23 March 2021. Congratulations to PAGASA and to Dr. Vicente Malano, Director General of PAGASA, on the 156th founding anniversary of PAGASA, also coinciding with the 71st World Meteorological Day. We all know we are suffering difficult times through the pandemic. This celebration provides an opportunity to focus on the great work that we have been doing for the benefit of society. This day is time for our meteorological community to showcase the essential contribution of meteorological and hydrological services to improve livelihoods. This year's theme, tropical weather, climate, or water-related issues, could not be more timely. We know that 2020 tied 2016 as the warmest year in the historical record. We observed record-breaking Atlantic tropical storm activity in the West Pacific, while the 2020 typhoon season was slightly below average. One typhoon is often too many for society. Our community does the very best job it can to prepare forecasts and to issue warning and advisories to prepare governments and the citizens of the world to take action in order to mitigate impacts of disasters. NOAA's Climate Prediction Center has a long history of collaboration with PAGASA. NOAA believes that adaptation to climate variability and change and mitigation of impacts from disasters will not happen until we develop the capacity of meteorological services around the world to provide reliable and accurate climate forecasts. We can take advantage of recent development in advancement of numerical models to achieve this goal. Our dynamical models have become much more sophisticated than a decade ago, thanks to a more robust data assimilation technique and increases in computing capabilities to run global model at much higher resolution. We have worked with PAGASA to develop tools for subseasonal forecasting. This time scale is extremely important as it is at the intersection between the short-range weather system and climate patterns. Put at the hands of users of climate information, we can improve decision support services in agriculture, water resource management, health, and energy. We plan to continue to provide support to PAGASA through our International Climate Training Workshop Series to develop capacity on subseasonal to seasonal timescale and the downscaling of the North American multimodal ensemble forecasts. We also will continue to work with PAGASA to provide access to real-time NCEP products for use as guidance in PAGASA forecast operations. We believe that PAGASA has made tremendous strides through its modernization plan. Capacity building in terms of human resources and infrastructure development is key to achieving success. And NOAA's Climate Prediction Center is keen to continuing to work and to support PAGASA's initiative. With this, we wish you a happy World Meteorological Day to all of you at PAGASA. May God bless. Thank you.
Thank you very much, Professor Taalas and Dr. Chow, for that very inspiring message. For the meantime, I turn you over to Miss Anna for some acknowledgement.
Tayo lang din nakakarinig yan. Mute, pamute si ma'am. Hindi. Under, okay mo. Narinig tayo. Narinig tayo. Tayo narinig. Wait lang.
Questions to our respected speakers, and they will try to answer those questions to you. So just all for now. Back to you, Christy. Thank you.
Okay, thank you, Anna. So we are now on the most awaited part of our program, which is the Scientific Forum. So we have 4 presentations, and after each presentation, 2 to 3 questions will be entertained, and this will be led by Ms. Ana Solis. And right after the Q&A, the presentation of the certificates of appreciation and token will be given by Dr. Nathaniel Servando, the Chief of the Research and Development and Training Division, and also the Chairman of this year's World Meteorological Day Organizing Committee. This pandemic may have brought us physically apart, but it never stopped us from coming together to share knowledge on ocean, climate, and weather. Well, in fact, most of our speakers are coming from the different parts of the world and from different time zones. It is a daytime now in the Philippines, but it may be a nighttime from the speaker's place. So without much further ado, allow me to introduce our first speaker. He is a senior scientist at NOAA's Pacific Marine Environmental Laboratory in Seattle, Washington. His research focuses on large-scale tropical ocean dynamics, ocean-atmosphere interactions, and the ocean's role in climate. He received a PhD in physical oceanography from the Scripps Institution of Oceanography in 1980. For more than 35 years, he has been involved in developing ocean observing systems for climate research and for forecasting, most notably, the tropical atmosphere ocean, moored buoy array in the Pacific for studies of El Niño and the Southern Oscillation. He is also the past president of the American Geophysical Union, or AGU, an organization of over 60,000 Earth and space scientists from 140 countries. He has published over 300 articles in the refereed scientific literature and is one of the most highly cited authors of the topic of El Niño. He is a Nansen Medalist of the European Geosciences Union, a Sbervra Medalist of the American Meteorological Society, and a Fellow of the Oceanography Society, the AMS, and the AGU, for his contribution to assessments of the Intergovernmental Panel on Climate Change, or IPCC, and he shared the Nobel Peace Prize in 2007 with Al Gore and other IPCC participants. So to speak to us on El Niño Southern Oscillation in a changing climate, let us all welcome Dr. Michael McPadden.
Have the latitude.
Thank you. Can you hear me? Can you hear me?
Yes.
Yes.
Okay, thank you. You know, I'm hearing some background noise, and I wonder if everyone is muted.
Right now. Well, you know, this is a research forum, so I would like to say.
Okay, I'm still hearing some background noise. Do you know if everyone is muted? Okay. Let's see. Can you see my screen?
Yes, Dr. McPadden.
See?
Okay. All right. Well, let us begin then. Thank you for that introduction, and thank you all for joining us today. I would like to speak about El Niño Southern Oscillation in a changing climate. ENSO is the strongest year-to-year fluctuation of the climate system on the planet, and its impacts are felt worldwide. Because of ENSO's significant socioeconomic consequences, how climate change may affect ENSO is one of the most compelling problems in Earth system science today. ENSO is a natural variation of the climate system. It's been occurring for millions of years. We refer to the warm phase of ENSO as El Niño, the cold phase La Niña. It is generated in the tropical Pacific through interactions between the ocean and the atmosphere, and its effects are felt worldwide. And in the center panels there, you see the global fingerprint of El Niño. Its effects are immediate in the tropical Pacific in terms of rainfall variations, and in fact, the Philippines is in some sense at ground zero in the Western Pacific because it's so close to the center of the action. But ENSO affects the far field through atmospheric teleconnections, and it influences the climate variability on all 7 continents and all ocean areas. These maps of ENSO's global fingerprint are for December, February. This is the peak season, typically, of El Nino and La Nina development. And what they really represent are shifts in the probability for a particular type of weather pattern to occur: droughts, floods, heat waves, or other extreme events like typhoons and hurricanes. Before we get into the specific topic of El Nino or ENSO and climate change, I want to talk a little bit about what's happening right now in the tropical Pacific, which is that we've been experiencing for the past year or so La Nina conditions. And you can see on the left the cold sea surface temperatures in January, just picking a recent month. And those sea surface temperatures are surrounded to the north and south and to the west in the Philippine region by warmer than normal temperatures. And associated with these sea surface temperatures, we have a strengthened trade wind system along the equator at the surface, and we also have a westward shift in the rainfall such that it's dry in the region of the Central Pacific, whereas it's now unusually wet in the Western Pacific, in Australia, Indonesia, and again in the Philippines. So this shows how the current La Nina compares to El Nino, La Ninas of the past 40 years. This is a Niño 3.4 sea surface temperature index. It is in the Central Pacific, where the ocean is particularly effective in causing changes in atmospheric circulation. The red peaks are the El Ninos. You can see the big El Ninos of 82, 83, 97, 98, and 2015, 16. And the blue troughs are the La Ninas. And so right at the end of the record here, you see the current event. And at peak, which it was in November, this event was about 1 degree Celsius. So it's a moderate amplitude event. It's not among the strongest, but it's also not among the weakest. It is beginning to fade. And these are the most recent forecasts put together by the International Research Institute for Climate and Society from many institutions around the world from March initial conditions this month. And although there are outliers, most of the forecast centers are predicting that this event will fade by the end of boreal spring 2021. However, if we look back, we can see that this event has had significant societal impacts, particularly in the Western Pacific, flooding and heavy rains in Australia and Indonesia. Typhoon Goni, which was already referred to, hit the Philippines in November. Typhoons tend to form further west and therefore are more likely to make landfall in the Philippines and other regions during La Nina events. And where I live in Seattle, Washington, we've had a very unusual winter in terms of the amount of rainfall. And this is, again, a classic La Nina impact. And although this event is beginning to fade, it may continue to have impacts. This is the precipitation forecast, global precipitation forecast for the next season, April, May, June. And if we home into the Asia-Pacific region in particular, you can see that even though the anomalies in sea surface temperature are beginning to fade, the Philippines is a region where there is a very high probability of above normal rainfall in the coming season. And so it's these climate impacts and their societal consequences that provide the broad context for our interest in the question of how climate change may affect ENSO. And the climate is changing. We heard in the very excellent opening comments this evening the fact that there are many indicators that humans are changing the climate system. The atmospheric temperatures, the 6 warmest years on record are the last 6 years. 2020 is the second warmest year, or close to tied for the first warmest year. Melting glaciers, disappearing Arctic sea ice, rising sea levels, more extreme events, the list goes on. And we know the reason why the climate is changing, and it's because humans are injecting heat-trapping gases into the atmosphere, particularly carbon dioxide. And these levels of CO2 now have risen permanently above 400 parts per million. These are the highest carbon dioxide levels experienced on the planet in the last 800,000 years. And this is because humans are burning fossil fuels and deforesting large areas of the planet. And the planet is likely to continue to warm. It's already warmed a degree Celsius above pre-industrial levels. And if, depending on how aggressively humans decarbonize our energy systems, atmospheric temperatures may rise anywhere from 1 to 4 degrees Celsius more in the coming century. And so it's a real question, because we're changing the Earth's energy balance. How will ENSO change? Because ENSO itself is a heat engine focused on the tropics. And so there are really two questions that we think about when we talk about how climate change may affect ENSO. And scientists have been wrestling with these for at least 30 years. The first one is, has climate change affected ENSO already? And the second is, how will climate change affect ENSO in the future? So let's take these in order. The first one. Well, we do have evidence from the instrumental record, which goes back about 165 years in terms of sea surface temperatures. And that's shown here. The red peaks are the El Niños, the blue troughs, La Niñas. If you look at the end of this record, the last 40, 50 years or so, you get a sense that maybe the ENSO cycle is stronger. And, but we have to be careful, because this latter part of the record is really the most well sampled. It's the satellite area. We have lots and lots of data in which to characterize the ENSO cycle. If we go back in time, we're really restricted in the amount of information that we had. We had to rely primarily on ships, and in the tropical Pacific, there are only a reasonable number of observations along a few well-traveled ship tracks. And so there are changes in instrumentation that affect the quality of this record. And if we go further back in time, we know that some events based on historical accounts were probably as strong as some of the more recent ones. And in particular, the 1877-78 El Niño has been chronicled by historians in many parts of the globe. And so there's ambiguities in this record. And what we really come to the conclusion here is that the instrumental record is too short to make definitive statements. And in fact, a modeling study by GFDL running a model with for 2,000 years with pre-industrial greenhouse gas concentrations estimated that it would take 500 years of data to determine a climate change signal emerging from the background of natural variability. We don't have 500 years of instrumental data. We do have paleo data, though, and we have thousands of years of paleo data. And analysis of these data are suggestive. This is a paper that came out last year, in which the quote is, ENSO extremes of the last 50 years are significantly stronger than those of the pre-industrial era. But there are caveats, and these are two. One is that these changes are difficult to detect against the background of large internal variability. There's, consistent with what I mentioned about the instrumental record, there's a tremendous amount of natural variability in the ENSO cycle, so it's difficult to detect unambiguously the signature of climate change. Also, paleoproxies are sparsely distributed in space, and so they're not capturing the full range of possibilities with ENSO variations, and they are often contaminated by biological, chemical, and physical factors not related to climate. So they're suggestive, but I would say not quite definitive yet. So in answer to the question, has climate change affected ENSO already? I think the answer is maybe, but the instrumental record is too short, and paleo proxies are suggestive but uncertain. So what about the question of how will climate change affect ENSO in the future? And for this, we need to rely on the IPCC class of climate change models. And they're useful because they can give us indications of how the climate system will change under different greenhouse gas forcing scenarios. But when you get down to the regional scale and you get down to a phenomenon like El Nino, which is generated through a delicate balance of amplifying and damping feedbacks, the model results can oftentimes be conflicting and confusing. I will point out one recent result here that seems rather definitive, and what these authors did was looked at only the 17 models that in the current climate give a very good representation of ENSO variability. And what they found in these models was that most of them show an increase in ENSO SST variance in the eastern equatorial Pacific. And that increase in variance is mainly due to the fact that in these models, the strongest ENSO events become stronger. And the physical reason for that is because the greenhouse gases warm the upper ocean more than the interior ocean, which increases the vertical temperature stratification and makes sea surface temperature more sensitive to vertical excursions of the thermocline as typically occur during El Nino and La Nina events. So that's one important result. Another important result is that when we think about extremes, we need to bear in mind the nonlinear relationship between sea surface temperature and rainfall. And that's shown here with historical data. On the left is a plot of rainfall in millimeters per day versus sea surface temperature in the Niño 3 region. And you can see that once you get above a certain threshold, the rainfall increases tremendously in this equatorial zone. And there are two reasons for that. One is that for these strong events, when the water becomes so warm in the cold tongue, the local air can hold more moisture. That's the Clausius-Clapeyron relationship. But there's a dynamical reason as well. When the cold tongue disappears, it makes it easy for the intertropical convergence zone and the South Pacific convergence zone to collapse on the equator. And so you get these tremendous increases in rainfall. And so the higher the temperature, the stronger the rain. And one of the features that is common to most of these IPCC models is that, putting aside for the moment ENSO variability, most of these models show that there is a gradual warming of the eastern tropical Pacific mean state. So most of the models show that the cold tongue region of the eastern Pacific warms more than to the north, south, and to the west. And what that means is a 2 degrees Celsius El Nino anomaly occurring on the background of elevated temperature that is evident in most of these models will produce a much, much larger rainfall signal than a 2 degrees Celsius El Nino anomaly today. And this is important because it is the rainfall in the tropical Pacific that drives the climate impacts and the far-field teleconnection. So rainfall is an important indicator of impacts and their intensity. And so using rainfall as an index, two studies have shown that extreme El Ninos, those that produce rainfall of more than 5 millimeters today in the eastern Pacific, these extreme events will double in frequency from once every 20 years today to once every 10 years by the end of the 21st century. And that because in the current climate and in a warmer climate, extreme La Ninas tend to follow extreme El Ninos. Extreme La Ninas will double in frequency as well. And so, in answer to the question, how will climate change affect ENSO in the future? ENSO sea surface temperature amplitude is likely to increase with strong events becoming stronger. And also, the strongest ENSO events are likely to double in frequency by the end of the 21st century, leading to more extreme impacts because of the increased intensity of rainfall in the eastern equatorial Pacific. Now, the second point is interesting because it emphasizes the nonlinear interaction between ENSO variability and changes in the background conditions on which ENSO develops. Well, today, in fact, over the past century, the global oceans have been warming. And there are uncertainties in regions where the data are sparse historically, and those include some of the regions in the tropical Pacific, but there is a very noticeable rise in global ocean temperatures. So this raises the question, are nonlinear actions of ENSO with observed background state changes amplifying ENSO impacts today? And I will make the point that the answer to this question is yes. And I will illustrate it with just a couple examples, and we'll take those from the 2015-16 El Niño. And one of them is maybe self-evident, and that is the extreme coral bleaching event of 2014-16. This was the longest and most widespread bleaching event on record. Over 40% of global reefs were affected, and the Great Barrier Reef was almost entirely bleached, and nearly a quarter of it died as a result. Now, coral bleaching occurs when the temperatures rise above a certain threshold, such that the one-celled plants that reside in the coral polyps are expelled, and these plants provide both the color and the nutrients to support coral. And if the temperatures remain elevated for too long, then the coral will die. The last two global bleaching events were in 1997 and 2009-2010. It's no coincidence that these were also El Niño years. The reason why the bleaching event in 2014-16 was so much more severe is because we had a big El Niño riding on the back of an ever-rising global sea surface temperature trend. Another example from the tropical Pacific is the record year for tropical storms in 2015. And this was a year that we saw a record high accumulated cyclone record accumulated cyclone energy, 20 Category 4 storms. We had the first named storm in the Southern Hemisphere winter, Raquel, in June of 2015. And we had 3 Category 4s appear on a single day in August of 2015. Now, we know that tropical storms feed off warm sea surface temperatures that are higher than 26.5 degrees Celsius. There was plenty of that water around because of the big El Niño. But again, the fuel was increased by the fact that we had a warming trend due to greenhouse gas forcing, raising the sea surface temperatures even more. And so these are 2 examples that show how with El Niño and La Niña occurring on the background of a warming global temperature trend for the oceans, we're seeing increased impacts as a result. So let me summarize then on this topic of how ENSO may be affected by climate change. The instrumental record is too short to determine whether climate change has already affected ENSO. The paleo record is suggestive that there may be amplified variability in the past 50 years, although there are uncertainties. Models suggest that strong ENSO events may become stronger by 2100 because of increased vertical stratification in the Pacific, which amplifies the thermocline feedback. Using rainfall as a measure of ENSO impacts, extreme El Niño and La Niña events may double in frequency by 2100. And the nonlinear interaction of ENSO with background state warming means that we can already see the compounding impacts of climate change on ENSO-related extreme events now. And I just mentioned a couple, there are others. And finally, let me conclude by saying if you're interested in this topic and you want to learn more, we just published a book, El Niño Southern Oscillation in a Changing Climate. This is published by AGU last November. It is the first comprehensive assessment of ENSO variability, dynamics, and impacts in a changing climate. It has 21 chapters written by 98 scientists from 58 institutions in 16 different countries. And some of what I covered today is contained in this book, but there is much, much more as well. And with that, I will conclude and thank you.
Yeah, thank you very much, Dr. Faden, for this really very informative presentation. So it is really very heartwarming and very...
The four areas of activity and overall being found or shows that...
I hear some background noise, please. Okay. So I'm sure all of you enjoyed his presentation to these very interesting topics. And I think there are lots of key messages and takeaways from Dr. McFadden's talk for now. And he also showed us has climate change affected ENSO already, and how will climate change affect ENSO in the future. And he also emphasized that combined effects of El Nino and global warming will cause more extreme events. So there are lots of messages and takeaways that we could take from Dr. McFadden's talk today. So thank you very much, Dr. McFadden. And I think we have lots of questions or inquiries. If you could accommodate at least one or two questions from our audience right now, Dr. McFadden.
Certainly.
Yeah, so based on there is one question here from our participants. Based on recent observations and studies, will there be more La Nina episodes than El Niños? Because the last 6 events were back-to-back La Nina, so we will be experiencing more of that.
Yeah. That's a good question. I don't think there is any evidence for that yet, that there will be a shift in the frequency of El Niños and La Niñas in the future. What we can say is that there is asymmetry in the ENSO cycle today, and that likely is to continue into the future. The asymmetry is most simply stated in that El Niño events tend to be stronger, but shorter lived. La Nina events tend to be, big La Nina events tend to be weaker than big El Nino events, but oftentimes La Nina will last for 2 years rather than 1. So La Nina tends to be longer lived, but slightly weaker than El Nino. And so that asymmetry we see today, and it's likely to continue in the future.
Okay, thank you very much. So there is also another set of questions here, maybe a last question that you could entertain, Dr. Michael. So yes. It is known, there is one question. It is known that largest scale improvements to models that have skill in predicting large scale models, such as ENSO, for example. But then there are little skill in predicting the associated teleconnection responses over a region of interest. So is there a way, or will there be any hopes that this skill could be further improved, those teleconnection patterns or responses coming in from the models itself?
Right. Well, the further away you move from the source of the variability, which is the tropical Pacific, the more the teleconnection signals can be obscured by weather noise in the region. And so, you know, that is a challenge, extracting the teleconnection signal from the noise. And one can always hope that our models improve. Noise is not the only difficulty in extracting a meaningful ENSO signal. Models, when used for forecasting, have known biases, and they have known sensitivities to parameterized subgrid scale physics like convective processes. So probably the greatest hope for improving our skill in predicting long-range teleconnections out of the tropics is to improve the models, to reduce their biases and make their parameterized physics more realistic.
Okay, thank you very much, Dr. McFadden. I hope Dr. McFadden already answered our questions clearly, and thank you for answering those questions. So maybe if there are some other questions that will be addressed to Dr. McFadden, so maybe we could ask Dr. McFadden later we could send some email to Dr. McFadden so that we could address some of your questions here. So
certainly, I'd be happy to do that. Thank you.
Thank you very much, really. So I will now turn you over to Dr. Servando for the awarding of certificates of appreciation and token of appreciation to Dr. McFadden. Back to you, Studio.
To present the certificate of appreciation as long as the token and some messages.
Thank you, Dr. Michael McFadden, for a very informative talk about El Niño Southern Oscillation in a changing climate. Now, I'm giving you the certificate of appreciation on behalf of PAGASA, being the organizer of this forum, and allow me to read this certificate. The Philippine Atmospheric, Geophysical, and Astronomical Services Administration, PAGASA, awards the certificate of appreciation to Michael G. McFadden in sincere appreciation and grateful recognition of his invaluable and unselfish support by sharing his expertise as resource speaker during the scientific forum linking Philippine climate and weather with tropical oceans, held on 23 March 2021, PAGASA Central Office, Philippines, via Zoom. Signed, Vicente B. Malano, PhD, Administrator. Again, thank you very much, Dr. McFadden. And along with the certificate, we are giving you a token of appreciation. Actually, it's a hand-crafted sculpture of a horse, I think, from the organizer. And again, we are very grateful for sharing your expertise in this event. In line our celebration of the 156th National and 71st World Meteorological Organization Day here in the Philippines.
Okay. Thank you, sir, for that message. And thank you also, Dr. McFadden, for that comprehensive talk on El Niño Southern Oscillation in a changing climate. So moving on to our next presentation, our guest speaker is a senior scientist in the Physical Oceanography Department of the Woods Hole Oceanographic Institution and one of the largest and most respected oceanographic institution in the world. Prior to arriving at the Woods Hole Oceanographic Institution in 2006, he was a postdoctoral scientist in the Climate and Global Dynamics Division of the National Center for Atmospheric Research. His PhD in Physical Oceanography is from the School of Oceanography at the University of Washington. His research primarily focuses or revolves around one question: what is the role of the ocean in climate? More specifically, his research focuses on the variability in the ocean and atmosphere and the interaction between the two in the extratropics on time scales of a few years to several decades. He has published about 70 research papers in peer-reviewed scientific journals and authored about 200 conference abstracts on various topics, including decadal climate variability, oceans' impact on extreme weather, Earth system predictability, and large-scale ocean circulation. So, to present today the role of the ocean in shaping the weather and climate system, let us all welcome Dr. Yang O. Kwon.
Thank you very much for the introduction. Let me share my slide first. Can you see my slide? Can anyone tell me whether you can see my slide?
Yes, it's clear.
Okay, thank you. So thank you for this opportunity to talk to you today about the role of the ocean in shaping the weather and climate. So ocean impacts weather and climate all time scales, as we already heard multiple times today. In the weather time scale, the extreme weather such as tropical storms is a good example. The sub-seasonal variability, including MJO, is a definitely coupled phenomenon between ocean and atmosphere. The mean seasonal cycle of our climate is heavily impacted by ocean through the ocean's heat storage and transport. The internal timescale, we just heard excellent talk from Dr. McFadden about ENSO. And then the decadal timescale, we have many climate variabilities such as Atlantic multi-decadal oscillation impacted by ocean. And this is a particular area I'm personally studying mainly. So I'm going to talk to you a little bit about this topic later in the talk. And of course, in the longer term, climate change, ocean is important, especially for the ocean heat uptake. While ocean is impacting weather and climate in all time scales, ocean's role is becoming more and more important as you are considering longer and longer time scale. Especially in terms of predictability aspect, ocean is the leading source of predictability for time scales longer than a few months. And why is that? It's simply ocean is dominated by longer variability while atmosphere is more chaotic. So here is one quick example more for the extratropical setting. So I took the seasurface temperature over a large box in central North Pacific. And that's the average time series for about 60 years from 1950 to about 2010. And the bottom plot is the surface wind speed for the same area. And you can see the characteristic is very different. The ocean is dominated by longer term, more persistent memory, while the atmosphere is dominated by shorter term and more chaotic characteristic. So it's not surprising that ocean is the dominant source of predictability in the longer term variability. Another way to look at how ocean affects the climate and weather is through the heat transport. So the schematic on the left is showing that heat is mainly coming into our climate system around the tropics, and we are losing more heat in the high latitude. And then the atmosphere and ocean is carrying those excessive heat from tropics to the high latitude. If we take a look how those heat transport by atmosphere and ocean is partitioned as a function of latitude. Here's the red is the atmospheric heat transport to the north, and green is the oceanic component, and blue is the total. So there's tropical band where the ocean and atmosphere carries about the equal amount of heat to the north. And it's tightly coupled system, as we heard from Dr. McFadden, and I'm sure you are all familiar with. Then if we look at the higher latitude, atmosphere takes most of the heat and ocean does not do much. But ocean is still important because even though it's relatively smaller amount of heat, it affects greatly how sea ice behaves, and sea ice is very important in our climate system. And there's the latitude band in between tropics and high latitude, where I am mostly interested in. It's the special area where ocean hands over lots of heat to the atmosphere. So after that, the atmosphere carries most of the heat, and that handover of the heat is happening mostly around the region called Western Boundary Current region. So let's talk about the Western Boundary Current region a little bit more. So for the next couple of slides, a few slides, I'm going to focus on how the air's interaction over the Western Boundary Current region impacts weather and climate. So Western Boundary Current region is where the ocean circulation is most energetic. So this plot is showing the sea surface height variability, which is a measure of how energetic the ocean current is. And all those red areas is where the ocean is very highly energetic. And undoubtedly, those are the areas of storm current with the special names like Gulf Stream, Crucial Extension, Agulhas Current, East Australian Current, and Brazil Current. Those are all the Western Boundary Current region where the ocean is most energetic. And also there's huge heat transferred from ocean to the atmosphere in those areas. Another special aspect of the Western Boundary Current region is that's where the atmospheric storm tracks are anchored upon. Because the ocean is providing lots of heating and also acts as a source of moisture. So this plot showing here from one of old papers is showing exactly that the Western Boundary Currents you can identify with the red, blue, and green lines. And what I'm shading here is so-called the synoptic storm tracks. So the heat transport by atmospheric transient eddies. And you can see they are highly correlated both in sensible and latent component. So with those collocation and huge heat flux from ocean to the atmosphere, how does the Western Boundary Current impact the weather and climate? One example I can show you today is a numerical model experiment. So what happens if we artificially smooth the sea surface temperature over the Western Boundary Current region? So on the left, on the top, we see the sea surface temperature over the North Atlantic. And the Gulf Stream is a very sharp SST front. And people did experiments with smoothed SST to see what happens if we don't represent this Gulf Stream SST front realistically. So one of the effect studies found by Chris O'Reilly et al. Found that the atmospheric blocking frequency has decreased about 30%. There's another paper by my former postdoc, Bruce Parfit, found that the atmospheric weather frontal frequency has decreased about 30% by smoothing the Gulf Stream SST. And also Chris O'Reilly found in the later paper that attitude would just shift southward. And using the same type of simulation in the North Pacific side, the Kuano Yoshida found that the storm tracks shift got weaker, but more interestingly, the most explosive extratropical cyclones that makes a lot of damage has been shifted south. So there's a lot of impact on weather and climate that these studies have shown from the western boundary current AS interaction. So let me shift the gear of my talk a little bit to the decadal climate predictability and prediction. Decadal prediction is also called near-term prediction or multi-year prediction. So I'm sure you are all familiar with how we do weather forecasting, and it is an initial value problem, and we do ensemble forecast. So we need as accurate as possible initial conditions, as we heard already today earlier, to get a good weather forecast. On the other hand, the long-term climate projection is a boundary value problem. So the trajectory of climate change is driven by the imposed radiative forcing on the climate system. So those two are two different problems, and the prediction for different timescales are affected by those two factors. So on the short time scale, the initial value problem. On the longer time scale, it's the boundary value condition problem. And in between, decadal prediction and seasonal to annual prediction, the effects are coming from both sides. So decadal prediction is not very old, and it's about a decade old, actually about 16 years. And this is example from Doug Smith et al. From UK Met Office team. This is one of the very first decadal prediction results published in Science back in 2007. So what they tried to do back then is using their decadal prediction system, they tried to predict the global mean surface temperature anomaly, the black from observation, and the red and yellow is their prediction system. So for 1 year lead time prediction, they did pretty good job, mostly because they were able to initialize correctly relate to the answer relate to the anomalies. But if you go to bottom with a 9 year lead time, there's not much predictability. So back then, 14 years ago, we didn't have much of decadal prediction skill. But the importance of decadal prediction is quickly recognized due to societal needs. So for example, WCRP named the near-term climate prediction as one of the 9 grand challenges. And also the CMIP6 has the panel on decadal climate prediction project. And so why do we increasingly emphasize the decadal prediction? Because it's important to decision makers in government and industry. And international research efforts begin to show that we can actually generate useful skills in this long time scale. And the climate change projection is subject to uncertainty in the future emission scenario. We don't really know what's going to happen. But the decadal prediction is less sensitive to those uncertainties, and it's still more of an initial value problem. I want to emphasize again that ocean is the leading source of predictability for timescales longer than a few months. So with this decadal prediction becoming more and more important, it's very important to understand how ocean is impacting the predictability of climate and weather in this longer time scale. So I want to end my talk with an example of decadal prediction of extreme weather from two of my recent studies. So it's about the predicting atmospheric blocking with a multi-year time scale, and the predictability comes from North Atlantic Ocean. So I've already talked about blocking a little bit, but just to make sure everyone is on the same page, the atmospheric blocking is mostly extratropical low-frequency weather phenomenon that blocks the normal progression of weather, so it makes the extreme event for a longer time. And over the North Atlantic, this is the winter climatology of the number of blocking days. So the days detected to have blocking is about 10 days over the British Isles and Scandinavia, and about 6 days over Greenland. So there's this enhanced blocking over particular regions. And we try to study the predictability for this high latitude blocking region. And we found out that actually the ocean, the phenomena called Atlantic multidecadal variability, is the main source of predictability. And interestingly, while the blocking is a weather phenomenon, the Atlantic multidecadal variability is a very long time scale climate variability over the 60 to 70 year time scale, and has this warmest assessed anomaly over the subpolar North Atlantic. So we used climate prediction, the decadal prediction system, and it's like weather forecast. So we use ensemble forecast, and most of modeling centers use about 10 members. That's all that they can afford, because this is a very expensive systems. But the system we used is the so-called community or system model decadal prediction large ensemble, CESMDPLE. This is a single model large ensemble with 40 members. So about 4 times larger ensemble than most of other models. And this is a fully coupled global climate model. So it includes atmosphere and ocean and land and sea ice component and ocean biogeochemistry. So we did retrospective prediction exercise starting from 62 different initial dates, starting from November 1st of 1954 and 1955 until 2015. Every year we started on November 1st and ran for 10 years for each initialization date. So what we found is, using this prediction system, retrospective prediction exercise, we found a very significant prediction scale for this high latitude blocking. So here is the result. So blue is from the reanalysis or observation, and red is from our prediction system. And you can see match is very significant. And the prediction scale mostly coming from the multidecadal timescale. And the North Atlantic Oscillation, which is the leading mode of variability in the atmosphere in this sector of the world, which is highly correlated with high latitude blocking, was also highly predictable using this prediction system. So where does the predictability comes from? as I already said at the beginning of this part, comes from the A and B ocean anomaly. And there's chain of events we identified. The A and B, because it's warmer, the warmest on the subpolar side, it modulates the meridional gradient of ocean and the low atmosphere. So it modulates the variability of the atmosphere. And the storm track changes. It changes the eddy-driven jet and the raspberry braking, thus blocking. So with that, I would like to end once again saying ocean impact weather and climate in all time scales. Thank you.
Okay, thank you very much, Dr. Yang O Kwon. So for that very interesting topic. So there are lots of about Dr. Kwon's talk that ocean is the leading source of predictability in longer time scales, and it's always been it's the chaotic atmosphere versus the ocean that we need complex predictability and variability. And he also discussed about the western boundary current air-sea interaction that critically impacts our weather and climate system, and about the predictability of the decadal predictions about the Atlantic Atlantic multi-decadal oscillation that provides us better predictability in terms of longer time scales. So maybe it's time for us to entertain some questions from our participants here. So maybe you could unmute your microphone if you want to ask some questions about Dr. Kwon's topic right now. But for now, there is one weather enthusiast asking about this, Dr. Kwon. So you have mentioned about western boundary current air-sea interaction. So is this the same area in the ocean when we heard of westerly wind bursts that fuels or triggers ENSO? Because maybe he heard a lot of books or internet information about the westerly wind bursts that sometimes it causes or triggers or fuels the start of El Nino, for example. So maybe he's asking for that area.
Well, westerly wind burst is definitely important aspect of our climate for ENSO. But that's mostly tropical phenomenon between the eastern Indian Ocean to the western tropical Pacific, and much shorter time scale. So western boundary current is the ocean phenomenon, unlike the westerly wind burst, which is atmospheric phenomenon. So the western boundary current is in the extratropics mid-latitude ocean, where the strongest ocean currents are always found on the western side of the ocean basin.
Okay, thank you very much. I think I saw one participant raising her hand. So kindly unmute your microphone and you could ask questions directly to Dr. Kwon, please. I think somebody raises her hand. Is it you, Maricar? Oh, okay. So maybe we could hear from her later. There is also one question raised here. Maybe she's not a technical people. Is a non-technical participants. She says here, if there are available climate change projections here in the Philippines, available in PAGASA and other institutions. So she asked if there are available climate change projections in the Philippines, in anywhere in the region, and there are decadal predictions available for 10 years, for example. So as a policymaker, should I use climate change projections, for example, for 2030, or I should ask for decadal predictions for 2030? That's what maybe he or she asked. And
So
yeah.
I'm not sure I got the question exactly, but the decadal prediction products from various global modeling standards are generally available publicly. So, and it's a global product. So anyone in the audience can take a look at how the prediction performs around the Philippines and decide whether that's useful or not.
Okay, sorry. So
No problem.
So for now, these two questions have already heard from our participants, and during this forum we still receive some questions from our participants, we could still entertain this, and after this forum we could send those those questions to Dr. Kwan so that he could address this email through the scientific committee of this program. So from here, I would like to thank Dr. Kwan. So I may now turn you over to Dr. Servando for your certificates of appreciation and token. Thank you very much, Dr. Kwan. So it was nice, and we have learned a lot from you, especially what are the secrets coming in from the ocean. So it's really been chaotic atmosphere versus persistent ocean. So we should rely more on the oceans because we may find lots of predictability secrets coming in from the ocean. So thank you very much for that wonderful talk. So back to you, Dr. Servando.
May I call on Dr. Servando to please give the certificates of appreciations and tokens to our speaker, Dr. Yang O. Kwon.
Once again, thank you very much, Dr. Yang O. Kwon, for that very informative presentation. And to express our gratitude for your invaluable contribution to this forum, we're now giving you the Certificate of Appreciation. Allow me to read this certificate. The Philippine Atmospheric, Geophysical, and Astronomical Services Administration, or PAGASA, presents this Certificate of Appreciation to Yang O. Kwon in sincere appreciation and grateful recognition of his invaluable and unselfish support, sharing his expertise as resource person during the scientific forum with the theme Linking Philippine Climate and Weather with the Tropical Ocean, held on 23rd March 2021 here at PAGASA Central Office, Philippines, via Zoom. Signed, Dr. Vicente B. Malano, PhD, Administrator of PAGASA. And along this Certificate of Appreciation, we are also giving you this wooden horse-shaped wooden handicraft made of kamagong. It's actually one of the hardest wood found in the Philippines, and it is handcrafted in one of the famous places in Paiti, Laguna. Again, the PAGASA expresses his appreciation to Dr. Yang O. Kwon.
Thank you very much, sir. So for now, before we proceed with the next two presentations, we may have a few minutes, 5 minutes break or health break. But please be back after 5 minutes because we're going to proceed with the next presentation promptly.
Anak mong alikain, kalikasan ng buhay sa pagbabago't pagtugon ng kalikasan.
Nakakabibatan, talino at husay sa pinsalay nagsisilbing paranggalang. Sa pagdilim ng mga ulang, sa gitna ng unos, ay kabalikan, kagapay kang lubos. Sa magtaas ng mga alon, at maging sa tagpiyon. Sa bawat panahon, mataas ang pag-asa ko. Ang paglilipod sa bayan na pinag-ilang, ay katiyak ang dulot ay kahantagan.
Ang nakakibat ng talino at husay sa pinsalay nagsisilbing paranggalang. Sa pagdilim ng mga ulang, sa gitna man ng unos, ay kabalikan, nagapay kang lubos. Sa pagtaas ng mga alon, at maging sa tagtuyon. Sa bawat panahon, mataas ang pag-asa. Sa pagdilim ng mga ulang, sa gitna man ng unos, ay kabalikan, nagapay kang lubos. Sa pagtaas ng mga alon, at maging sa tagtuyon. Sa bawat panahon, mataas ang pag-asa ko. Sa pagdilim ng mga ulang, sa gitna man ng unos, ay kabalikan, kagapay kang lubos. Sa pagtaas ng mga alon, at maging sa tagtuyon. Sa bawat panahon, mataas ang pag-asa ko. Pag-asa ko. Pag-asa ko.
The Philippines, through the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, is a member of the World Meteorological Organization, a specialized body of the United Nations. Priding ourselves as the forerunner of weather and climate science in the region, we have spent decades of training, research, international collaboration. Originally stationed in Padre Faura, DOST-PAGASA is a critical national agency issuing tropical cyclone, flood, and climate forecasts and warnings. Growing proud to be a credible national meteorological and hydrometeorological service, peopled with highly trained weather forecasters and observers who keep up-to-date information on daily forecasts. Our meteorologists continue to study weather and climate phenomena relevant to people's safety and understand the structure and development of tropical cyclone to mitigate the effects of hydromet hazards. Our hydrologists understand the structure and development of typhoons to possibly mitigate the effects of disastrous floods. Our global reach has effective linkages with scientific organizations, promoting exchange of scientific information and cooperation among personnel engaged in atmospheric, geophysical, astronomical and space studies, PAGASA's 5 regional stations across the country, which are ready to give evidence-based localized weather information and related services, are highly dependable. 57 synoptic stations gathers all the meteorological elements at fixed observation times. 23 agromet stations provide agricultural meteorological advice. 8 upper air stations conduct observation of atmospheric pressure, temperature, humidity, and wind speed and direction, or a combination of all these variables at several layers of the upper atmosphere by electronic means. A wind tunnel used in aerodynamic research to study the effects of air moving past solid objects. 1 wind profiler. 155 automatic weather stations. 187 automatic rain gauges. 47 water level sensors. 2 automatic weather observing system. 2 high-frequency Doppler radar. 16 Doppler weather radars. 6 meteorological satellite facilities. 1 planetarium. We are with the Filipino people all day and night in multiple platforms so we can cascade information far and wide. Our influence in social media is getting significant, but we maintain our presence in TV, radio, and newspapers. Our work is beyond hard science. We inform people to keep them safe and their properties protected at all times. We are expanding and pumped up enough for the new wave of innovation of weather sciences as we realize our modernization plan.
Now we're back. I hope everybody is now in front of their screens because we have 2 more topics. So if you think the topics are getting more exciting, just wait because we have 2 more. So our next our next presentation, which is entitled The Role of the Oceans. Okay. Okay. Our next presentation will be delivered by, okay. Sorry for the technical problem. And if you think you are already bursting with knowledge or information on ocean, climate, weather, wait, because we have 2 more presentations. So our next presentation will be delivered by a team leader for the Climate Prediction Center, International Desk at the National Centers for Environmental Prediction, or NCEP. The desk consists of project support for the humanitarian missions of the U.S. Agency for International Development, or USAID, namely Famine Early Warning System Network of Food for Peace and the Disaster Risk Reduction Program of the Office of Foreign Disaster Assistance, Weather and Climate Product Development for the Globe, and Professional Development Training in Operational Weather and Climate Monitoring and Forecasting for Developing Countries. He assists National Weather Service and NOAA meet the U.S. international commitment for advancing science and technology, improving climate services, and reducing impacts of natural disasters around the world. His bachelor's degree in meteorology from meteorology from the University of Dakar, Senegal, West Africa. His master's degree and doctorate degree in meteorology from the University of Blaise Pascal Clermont-Ferrand, Paris, France. In 2019, he was as a recipient of a special award by the American Geophysical Union, or AGU, for his tireless commitment to building capacity in Africa and the developing world, leading to improved climate services and reduce risk from natural disasters. So everybody, please welcome Dr. Wasila Tiao to present Forecasting Climate Variability.
Good evening. Thank you very much for that very nice introduction. I appreciate it. It's always a pleasure for me to participate in PAGASA activities. I remember, I believe this was 2 years ago, I was in the Philippines, in Manila, celebrating World Meteorological Day with you guys, and certainly with COVID-19, I couldn't be there. But I am really happy that we can do this virtually. I would like to make just one correction from the introduction. The award that you have mentioned was not from the American Geophysical Union, it was from the American Meteorological Society. So I just wanted to get the record straight. So I'm going to share my screen. Okay, can you see my screen? You cannot see my screen?
Seen already.
I'm sorry, I couldn't hear. Can you see my screen?
Yes, we can see.
Okay, thank you very much. All right, so my presentation this morning, well, tonight for me, because I'm about to go to bed right after this presentation, but it's going to be about forecasting climate variability. And of course, this is following the presentation by Dr. Mike McFadden and also the presentation by Dr. Yang O. So, you know, we're moving from the deep science now into the forecasting process, the application. So again, my name is Wasila Chow. I work for the Climate Prediction Center, which is part of the National Center for Environmental Prediction, the National Ocean and Atmosphere Administration. So, as many of you know, it was long after we unraveled the mystery of weather forecasting that scientists started to realize that the key to the long-range forecasting, that is forecast 1 month, one month to several months lead time, was in the slow variations in the Earth's boundary condition and their influence on the global atmospheric circulation and thus the global surface climate. So these boundary conditions, my predecessors have mentioned them, have mentioned one of them, that is the sea surface temperature. I think that is the most known in terms of long-range forecasting. However, the other boundary conditions that are also very important and not to neglect, because certain regions of the world are very sensitive to them, is soil moisture, snow and ice cover, and vegetation. So anticipating the future evolution of the boundary conditions and the knowledge of their relationships with the surface climate provide the basis for predicting seasonal rainfall or temperature, seasonal climate. So here I'm going to talk about approach to seasonal predictions. Because when you talk about really short range climate forecasting, we're really talking about seasonal prediction here or monthly prediction, but I'm going to limit myself here to seasonal prediction. So there are several approaches to seasonal prediction. One is to use statistical tools. So these are based on analysis of the long-term relationship between observed boundary forcing and the surface climate. And for that, we have several techniques that we can use. The most simple one is a multiple linear regression, but we also do have physically based statistical tools such as the canonical correlation analysis, the Markov chain models, and also the constructed analog. So those physically based statistical models, they try to relate historical patterns in the predictive field. Could be sea surface temperature, could be also soil moisture, or runoff, or vegetation, and how that relate to surface climate, precipitation, and temperature. So it's a very cheap technique. Actually, anybody can run these techniques and make forecasts. The constraint is that they provide little understanding of the physical processes that are involved, and also it requires long historical record to make these the forecasts robust. So the other tools that I would like to talk about are the dynamical tools. So and these are essentially the coupled ocean, atmosphere, land, and sea ice models. So of course this is also an evolution, because there was a time when we were running global atmospheric general circulation models, and we would force them with sea surface temperatures. So it was a two-tiered forecast system to predict for the climate system. But over the past decade or so, we have really worked to advance forecasting, and now we're running a coupled ocean, atmospheric, land, sea ice model. So they use sophisticated mathematical equations to describe the current state in each of the components of the models, and they use the coupler to define how components interact to produce the current climate. So the challenges really reside in the chaotic nature of the atmosphere. As we know that small error in the initial states grows progressively and can affect the large-scale climate. So So this is why adding slowly evolving boundary conditions will lead to measurable forecast skill at the long lead time. So in dynamical approach also provide you with opportunities to reduce forecast uncertainty. And we do that using several procedures. One is to do an ensemble. So we run model multiple times with slightly different initial state to reduce the uncertainty due to initial condition error. We can also do super ensembles, that is, we use different models and physical processes and apply bias correction and calibration with observations to reduce the model uncertainty. We also can downscale these the outputs from the coupled ocean land sea ice model, and we can choose between performing a dynamical downscaling, which involves the use of a high resolution regional climate model where boundary conditions are provided by a global model. It helps improve the spatial and temporal detail distribution of the climate anomalies. We can also perform a much cheaper statistical downscaling, which is not less performing than a regional downscaling, where we would force a statistical model with predicted values from a dynamical model to correct the dynamical forecasts. So all of these approaches that I have talked about are approaches that are being used in an operational forecast setting. So now I just want to talk about really the basis for the predictability and the seasonal time scale. So I talked about the boundary conditions, and my predecessor talked about sea surface temperature, and I'm going to also stick with the sea surface temperature in the interest of time, because we just need to realize that much of the predictability in the climate system comes from sea surface temperature anomalies, especially in the tropics. Dr. Mike McFadden talked about ENSO, the El Nino Southern Oscillation. So it is the largest mode of variability on the interannual time scale. So if you're going to be able to predict rainfall or temperature on the seasonal time scale, we better have a good handle of how to predict this large scale phenomenon. So I'm not going to go into detail because you all know more than me about the El Nino Southern Oscillation. But just to recap for the sake of this presentation, to say that eastward expansion of warm sea surface temperature during El Nino can result in an anomalous eastward shift of rainfall or convection, and the enhanced thunderstorm activity in the Central Pacific will perturb the upper level flow, resulting in suppressed rainfall over Indonesia. So the sustained warming of the water over the light tropical Pacific Ocean also will lead to much above average rainfall in the tropical Pacific that in turn can influence the global circulation and rainfall in remote areas. And this is a schematic here, a three-dimensional schematic where you see the ocean depths here, the sea surface, the surface of the ocean, and the atmosphere. And you can see when you do have an El Nino with warming in the tropical Pacific extending from west to east, and you have cooling over the western part of the Pacific around the maritime continent, you see that you have westerly wind anomalies converging with easterly anomalies, and you have convection occurring here where you have ascendance, and you have descending motion here with Indonesia, and you see this can be descending also somewhere else. So you see this large-scale disruption in the global circulation that will affect many parts of the world, especially in the tropics. So because the Pacific is so large, so ENSO is really our biggest source of predictability on the interannual time scale. So what we do is that we take the Niño 3.4 region, which is the area in the equatorial Pacific between 5 south and 5 north, 120 west and 165 west. And then we can regress, that index over the global using a global precipitation data set. So when we do that, this is a regression for the October, November, December season. The top panel is the regression and the bottom panel is the correlation between the Niño 3.4 sea surface temperature index and the global precipitation. So when we do that, you can see areas that are shaded in brown are areas that are negatively correlated with El Niño. That is when you have warming in the tropical Pacific, then when you have an El Niño, you tend to have below average rainfall over the maritime continent, Southeast Asia, including the Philippines. But also you see that this dryness also does occur over Southeastern Africa and also over the northern part of South America into Central America. Conversely though, when we do have this warming, we see that the equatorial East Africa becomes wet, but also the southeastern part of Brazil, northern Argentina become wet, and we also do some wetness occurring here in the Southeast United States. So this is the correlation map that tell you how strong the relationship can be. So if we just focus here in this region of the maritime continent, we can see that the correlation coefficient is quite relatively high. So we know that this signal here is robust and then strong. That is, when we have an El Niño event, we're going to tend to have below average rainfall in this region, and vice versa. When we do have La Niña, we're going to tend to have above average rainfall in this region. So this is the same teleconnection map, regression map, and correlation, but for a different season. This is July, September precipitation. So the signal does change a little bit over the Philippines, not as robust as what we have seen for October, November, December. But I think that this is also probably related to influence of tropical cyclones as well. So now I'm just going to give an example of prediction of seasonal rainfall using statistical model. And here I'm featuring an experiment or a prediction using canonical correlation analysis, or CCA, which is a statistical model that relates patterns in the predictive field. In this particular case, we use observed sea surface temperature to predict for rainfall, and the prediction data here could be anything, could be station data from the Philippines, could also be satellite rainfall estimates. In this particular case, we're using gridded data set from the CPC. It is based on station data available through the WMO Global Telecommunication System that we put into a grid using an optimum interpolation technique. So when we run this experiment with global sea surface temperature, this is the first mode. This is the first canonical mode in the sea surface temperature, and how it relates to rainfall over the maritime continent. So we can see that we do have some above average eigenvectors in the equatorial Pacific, through the dateline, extending to the dateline. In the Western Pacific, the loading becomes negative, but they also negative in the northern part of the Indian Ocean, and also in the Atlantic just south of the equator. So when we do have a pattern similar to this one in the first mode, this is the corresponding mode in the rainfall. So in other words, what it tells us is that when you tend to have warming in the equatorial Pacific and cooling in the Western Pacific, you tend to have below average rainfall in the maritime continent, in Philippines, and vice versa. This signal here for the ENSO signal, rather the signal in the tropical Pacific is not as robust as what I have seen, south of the Philippines. So it seems like the signal that we see here, and you can see that here as evidence in the canonical time series, is that it is much like a trend signal that might be coming from the Western Pacific. And I think that probably also related to the warming trend that we see in the warming in the Western Pacific. It may have an influence in the Philippines. Anyhow, so this is what the first mode give you. I haven't. I'm not going to show you the second mode, but this is the skill. This is the cross-validated correlation skill between the observed rainfall and the predicted rainfall throughout the history of 1982 to 2020. So. So this is this run here give you your coefficient that you now can apply to the current condition in order to get to make forecasts, real-time forecasts, and I'll show you that later. So I just wanted to now move on to the dynamical forecast with the use of the North American Ensemble forecast or the NNME. So the NNME is a combination of different models, and this is an initiative that NOAA launched a few years ago. We invited several institutions that run climate models on the seasonal to interreal time scale to work with us and to support our forecast operations. So we initiated this consortium, the North American Maritime Ensemble, which we're leading at NCEP with our model, the Climate Forecast System version 2. But we also, Canada also contribute two models. One is the Canadian Climate Model version 4I, and the Global Environmental Multi-Scale Nucleus for European modeling of the ocean, which is called GEMNIMO. We also use one model from the GFDL and one model from NASA and NCAR, and then we take the ensemble mean. So the monthly and seasonal forecast from the ensemble mean is nothing but just the average of all contributions from the models. So these are just some numbers from the models, giving you the initial state and also the number of members for all the models. So the NCEP model, for instance, is initialized from the 1st to the 8th of the month and has the 2 members. The 2 Canadian models, if the initial condition are always the 1st of the month for 20 members, and so forth and so forth. And the total give you about 102 members. So in the NME, you have a total of 102 members. All of this is available and accessible, and you can choose to use any model that you want, or you can just choose to use the ensemble mean, or you can do your own combination in doing so. So as I said before, much of the predictability is really in the Pacific. So, so this is just showing you a skill map or correlation between observed sea surface temperature and predicted sea surface temperature from the North American Maritime Ensemble May initial condition for July, August, September. And we can see shaded in red and dark red is really where we have high correlation values, about 80 to even approaching 90% in the tropical Pacific. And you can see that this correlation is lower in the other ocean basin, the Indian Ocean, for instance, and also the Atlantic Ocean as well. So, but it's important that the models can really get the tropical Pacific, because that means that if you do have an El Nino or La Nina event that is present, we have a good source of predictability that might be useful to predicting climate anomalies. So these are just some correlation skill from the different models from the NME, and you can see that anywhere you see red values is good, because this is correlation between observations and predictions. And you can see that the models obviously perform differently from one another. But what is even more important and striking here is that over this particular region, you can see that the model ensemble mean tend to perform better than the prediction using observed sea surface temperature. So I just wanted to point that out, that one of the benefits of using multimodal ensemble in predicting the climate system. So that was for temperature. This is for rainfall. Of course, predictability is less in rainfall than in temperature. But you can see that the different models have, again, different strengths in predicting the rainfall in this particular region. And again, comparing the statistical model run forced with the observed sea surface temperature with the model ensemble mean, you can see that the model tend to actually outperform the statistical model forced with observed sea surface temperature. So all these models are available on our website, the CPC International website, that we have created to provide access to real-time global and regionalized weather and climate forecast to enable decision-making in agriculture and water around the world. So there are several things that you can that might be of interest to you on this website. But this is the NNME page where you could really go and look at real-time monthly and seasonal forecasts for the globe, but also for any particular region that is of interest to you. These are the forecast from the NNME. These are the current forecast. March initial condition, April, June 2021, and June, August 2021, March initial condition. Obviously, as you know, we do have an ongoing La Nina event going on. And certainly that reflects also in the forecast, especially in the Philippines, is showing a higher chance for rainfall to be above average during April, June 2021. When we come to the summer, though, as the lead time has increased, the signal faded over the Philippine area. So I think that also because maybe the relationship is not very strong, and maybe the closer we are to the June, August, the signal will probably become stronger. Maybe if we wait until May, we'll have a better idea of how the model is going to be performing for the June to August 2021 season. So the NME data is available through our FTP server. The forecast that we have shown is just a calibrated forecast, bias corrected forecast, but you can do a lot more by using your own data from the Philippines. And you can access the data here using a graph control file, SST precision and 2-minute temperature, but also we do have the data available also in CPT, that is the climate predictive tool format. So just to conclude here, I talked about several approaches to seasonal climate forecasting. Forecasts are region dependent, and so they will play an important role. Certainly, areas that are very sensitive to El Nino and so tend to do much better in terms of forecasting than areas that are more remote to ENSO. What I also find is that islands such as the Philippines and even Indonesia, even though the large-scale signals show you a great relationship with ENSO, it tends to be that if you look at individual islands, you tend to lose that signal. So I think that also something that
Silong screenshot.
What is that?
Yes, continue, Dr. Chow.
Can you hear me? Hello?
Yes, Dr. Vasila, we could clear. Yeah.
You can hear
we
me?
could hear you, Dr. Vasila. Please.
Okay.
Yes, Dr. Vasila, can you hear us?
Yeah, I can hear you. Can you hear me?
Yeah, please proceed.
All right, so I'm about done. So the NME forecast provide additional guidance to meteorological services around the world to improve seasonal forecast. So we have timely access to this data. It allows for downscaling at the regional and also at the national level. So I think it's a great tool to have, even though we work with some of our partners are not operational forecasting centers, but we make sure that they provide their contribution to the NME to make this forecast using the benefit from these different models. So thank you very much. Thank you.
Thank you very much, Dr. Vasila. That was a wonderful and nice, very comprehensive presentation about forecasting climate variability. Actually, hello, there are some. Hello, I could hear feedback. So actually, Dr. Vasila is one of the key persons here to make this scientific forum filled with well-respected and expert resource person. So he extended his support to the technical forum committee of this event. So we are very grateful to have you, those three resource speaker from US. So actually, this is not his first time to be engaged with PAGASA, and he also already mentioned that. So about his talk, so he discussed about the approaches of seasonal predictions, some of the tools available, for example, different sets of statistical tools and dynamical tools, different sources of predictability at seasonal timescales, as well as the challenges in the chaotic nature of the atmosphere. So he also discussed about reducing forecast uncertainty, different approaches, and how to reduce such kind of forecast uncertainty. And also he showed us the skill of the multimodal ensemble in terms of Philippine rainfall, and actually we are using those NMME forecasts in our operational forecasting system here. So we are very grateful to avail those sets of forecasts from NOAA and SEP. And now it's time for us to entertain questions about forecasting climate variability, topic discussed by Dr. Vasila. So maybe I could get some questions from the chat. I have one here. So Dr. Vasila, so I think this is one of our maybe question. So there are available, you have mentioned that there are lots of available NMME forecast products that, I mean, since we are using that in our operational forecasting, so those forecasts are mostly forecast surface variables. So is there a way or is there a plan for NCEP to provide also some forecast atmospheric variables so that we could also use that in our operational seasonal prediction? So maybe even if it's just for the NMHS or since as a global producing centers. Thank you.
Thank you, Annalisa. That's an excellent question, actually. Yes, in fact, the NCEP climate forecast system version 2 does provide atmospheric variables as well. So the Canadian model also, I do believe, does provide that. Now, the other models that put it in the NME, we're in a process of doing that. So that is going to be the next phase of the NME. They have been asking, surveying scientists that are using the NME data for key variables that might be of interest to them. So I think that that is on the way, and many people responded to the survey. So they will now look at all these requests and see how we're going to resource that. So in the next phase of the NME, all of these models are going to be providing a certain number of variable, atmospheric circulation variable. I don't know to what extent it will be. I don't know if it's going to be to the extent of what is available from the CFS version 2. But certainly, I think that it will be a good step forward. That was a good question. Thank you.
Yeah, thank you very much, Dr. Basila, for that good news. So I think if there is somebody from the participants here who wants to ask questions directly to Dr. Basila, you can unmute your microphone now if you want to, please. Okay, so none for now, but I still have one more question to you, Dr. Basila. So one of the crucial aspects in seasonal forecasting is correcting the biases and also the nature of the bias corrections that we are using. So since those bias corrections are location specific and also depends on lead time of the forecast, so what do you think are other considerations in choosing which kind of bias correction will be appropriate or applicable for a particular region?
Yeah, well, it's hard to tell. The NME that we use are bias corrected. We just look at, I mean, there are errors in the model, so we just remove those errors from the models. Certainly, when you're making forecast for a specific region, you can use maybe more sophisticated bias correction techniques. You could perhaps look at several forecasts run and then over your particular region using your observations and see how the model really tilted away from the observation and use that in your bias correction technique. I think that there are a lot of things that you can do with the NME model, really to how to say to tailor the forecast more to your region specific using your own observations. So I would say that that's probably something that we can do, and we can talk about that. We can talk about bias correction technique that we use at CPC and see if that might be helpful to PAGASA. The other thing that you also can do is to downscale these NME forecasts to correct the forecast using a statistical model. You can also use the regional climate model, but I would actually encourage you more to use the statistical model to downscale those forecasts. If you do that, you will see that most of the time, you will see that it helps really improve the detail in the spatial and the spatial distribution of the forecast. That would be my best advice in terms of really trying to improve the forecast over your region of interest. But this requires trying several approaches, several things. I mean, even Philippine itself, span a wide latitudinal band. The southern part of the Philippines may be responding to different climate features than the northern part of the Philippines. So topography also does play a role. So you have to really have an approach that is really tailored to the region, to the specific region that you're looking at, and having a good observational data set, I think, is really key to achieving that goal. Thank you.
Okay, thank you very much, Dr. Wasila. And I think there is one last question, so maybe Dr. McFadden and Dr. O and Dr. Wasila could also contribute or try to answer these questions, because this may be helpful to our stakeholders right now. So in terms of our forecast probabilities and so, for example, so in ideal situation where forecast probabilities for an event, for example, during ENSO, they are reliable because we may find some good predictability, and they also convey information about the success of our forecast. So meaning we have good scale if there is large good ENSO predictability, and we have ENSO condition D. So the scale is okay, so when there is ENSO, but that does not guarantee the forecast value. So as an information provider and producer of this forecast, so what do you think is the most effective way of conveying this information to our stakeholders, to our users? Valuing between forecast scale versus forecast value. So it's really hard for them to explain how could we weigh in between the forecast scale or the forecast value, meaning the economic benefits from our forecast.
Yeah, I can go first, and then Mike and Yang O, they can contribute, but it's a tough question. I think that here the question is really how to communicate uncertainty in our forecast to the users. Obviously, we're talking about long-range forecasting. So, there is so much uncertainty that we have to express this forecast in terms of probabilities. So we use three category probability forecast, the two extreme category, that is above and below average, and the middle category, which is for near average. And then we look at how the probability density function is tilted, in those within those three categories. And we see whether the tilt is highest, it is in the above or the below average category, or in the middle category. Very seldom that we have that in the middle category, right? So in areas where predictability is marginal, oftentimes you will see that the departures from the climatological probability, that is about 33%, is not very high. So you may have a 45% chance for rainfall to be above average, for instance, and then you have a 25% chance for rainfall to be below average. And then, so how do you convey that to your user so that they can make sense of this? So, I mean, we have been working on this for a long time through the regional climate outlook forums, and I do believe that in the Philippines you also do have that. I think that we have to educate our users in understanding those probabilities, what they mean. If because regardless, even if you don't have a forecast, you're going to make a decision. So would you rather make a decision by just assuming climatology, or would you rather make a decision knowing that there is a high chance for, this event to occur, whether it is above or below average? So, I think that it's something that we need to learn. We need our users to try to understand when they're making decisions. If there's a 50% chance for drought to occur, they need to also know that there might be a 20% chance that it will not be dry. It might be wet. But even if you have a drought, you might have one event where it will be flooding. And so, and that's something that a seasonal forecast will not tell you. So I think my best approach here, to me, I look at it as a seamless forecast. It's a suite of forecasts. You do the weather forecast, you do the monthly and seasonal forecast, but I think that you also need to do the forecast in between. That is the mid-range, if you will. That is the week 2, week 3, 4 forecast. All that continuous forecast, and you need to be feeding that information to the user. If you predict, for instance, for drought on the seasonal time scale, and you follow that by providing weather forecast and also forecast at week 2 and week 3, 4, so you are essentially trying to really tell your user that, hey, by this time maybe you might be able to adjust your decision based on our week 2 and week 3, 4 forecasts. So we have to work together. The user, they tend to want to get deterministic information, that they want you to tell them whether it is wet or dry. But in our field, it's so difficult to do that. We have to stick with providing probabilities, educating them on how to use and how to understand what these probabilities mean, but also supplement that information with shorter range forecast that will help them adjust decisions, as time goes. Thank you.
Thank you. So I think there is some comments, maybe from Dr. McFadden. May we hear from Dr. McFadden as well as Dr. Kwong, if you have some thoughts on this.
Well, this is Mike McFadden. I think Stella said it very well. I really don't have much to add, but in climate and even weather forecasting, we speak in terms of probabilities, and I think educating users to the limits of our ability to make perfectly accurate forecasts is very important. And I think educated users understand those differences. I mean, if you follow the weather and if you make decisions based on the weather, it's always in terms of probabilities, 30% probability of rain, and you'll make decisions based on that, and you make decisions that are not only based on the weather or climate information. There may be other factors that drive your decisions as well, with the environmental information just being one. So I do think it's a challenge. I think it's a challenge that takes us into the realm of the interface between weather and climate science and social science, how we communicate effectively. But I think it's an absolutely necessary area for us to expand and explore, because the value of what it is that we generate as scientists for addressing societal needs is really predicated on the assumption that users can make beneficial applications of this information in such a way that they'll want to come back for more. Unfortunately, as a probabilistic science, the application of weather and climate information, all it takes is for one bad experience to turn people off. And so that's why the education in terms of what the expectations are of the value of this information is really, really important. So thank you.
Thank you very much for those wonderful thoughts from Dr. McFadden and Dr. Wasila. If you have something to add, Dr. Kwon? Is Dr. Kwon still here? Or maybe he'll left already. So thank you very much for those wonderful response from those experts. So maybe I will now turn you over to Dr. Servando for the certificates of appreciation and token. Dr. Wasila, thank you very much. So can I turn you over to Dr. Servando, please?
Thank you, Annalisa.
Okay, back to studio. So to award the certificate of appreciation as well as the token, I turn you now over to Dr. Servando.
Once again, thank you very much, Dr. Wasila Chow, for a very nice presentation and for sharing your expertise on the topic that was presented. Again, we're giving you to express our gratitude for your support to this scientific forum. We are now giving you the certificate of appreciation on behalf of PAGASA, which is the organizer of this forum. And allow me to read the certificate for you. The Philippine Atmospheric, Geophysical, and Astronomical Services Administration, PAGASA, awards this certificate of appreciation to Dr. Wasila Chow in sincere appreciation and grateful recognition of his invaluable and unselfish support for sharing his expertise as resource speaker during the scientific forum with the theme Linking Philippine Climate and Weather with Tropical Oceans. Held on 23 March 2021, PAGASA Central Office, Philippines, via Zoom. Signed, Vicente B. Malano, PhD, Administrator. And also, along this certificate, we have prepared a horse-shaped wooden handicraft made of hardwood in the Philippines. Again, thank you very much, Dr. Wasila Chow, and we look forward for a continued collaboration between PAGASA and INSEP NOAA.
Thank you, sir. So after those comprehensive presentations from the speakers from the different countries or overseas, and of course, it wouldn't be complete if we didn't prepare a presentation from the Philippines. So our next presenter will equip us with the information of what is in PAGASA to deliver its services on marine-related activities. Our next speaker is from the Marine Weather Forecaster, Weather Division, Department of Science and Technology, PAGASA. He acts as the officer in charge of the Marine Meteorological and Services section, and also the head of the Tropical Cyclone Group, and he also acts as typhoon forecaster and formulates tropical cyclone bulletins, alerts, warnings, and advisories during the occurrences of tropical cyclone inside the Philippine area of responsibility. He also conducts tropical cyclone post-analysis, summary reports, and annual reports. And he's also available for lectures and on tropical cyclones and other related activities. So please welcome our next speaker, no other than our very own Mr. Juanito Galang from the PAGASA Weather Division to present the PAGASA Marine Meteorological Services.
Hello, I'll just share my screen. Is it okay now? The screen?
Ayan. Okay na, Jim.
Thank you. So, is it okay? I will not open the video because my internet connection is unstable. So today we were able to celebrate the 156th National and the 71st World Meteorological Day with the theme The Ocean, Our Climate and Weather, although it's only online. Anyway, I'm Juanito Galang, assigned at the Marine Meteorological Section of PAGASA, and I'm currently the officer in charge of this section. So the outline of my presentations consists of 3 parts. First, the presentation of the marine products. Second, the communication and disseminations. And third is the plans in the marine met section. So the first product I will discuss is the shipping forecast. So this product, we issue this twice a day, every 4 a.m. and 4 p.m. And in this product, we provide informations for the 14 shipping zones. Informations like the weather conditions, the wind direction and speeds, the wave height, and the sea condition of that areas. And these are the Philippine shipping zones. From the north is Taiwan, Ryukyu, Base, Balintang, and all the way to the south, the Palawan, Sulu, Moro, and South Philippines. So we are planning to include one shipping zones. Wait. Excuse me. So we are planning to include one shipping zones here in the Taiwan Strait, which is located the west of the Taiwan area. So the next product is the gale warning. So when the winds of 63 km per hour or higher are expected to affect any seabirds of the country, we issue the gale warning. So we issue this every 5 a.m. and 5 p.m. So these are the seaboards where Philippines are giving the gale warning. There are 3 seaboards in northern Luzon, 2 seaboards in central Luzon, 3 seaboards in southern, 3 in Visayas, and 4 seaboards in Mindanao. So before I discuss the next product, let me first explain the domain we are using in giving warnings. So the red one is the Philippine Area of Responsibility, the official and warning area of responsibility of PAGASA, which issues domestic tropical cyclone warnings. The green one is the Tropical Cyclone Advisory domain. So in this domain, we issue the Tropical Cyclone Advisory. And the blue one is the Tropical Cyclone Information. And in this domain, we routinely analyze the center position, the intensity, the motion every 6 hours. And this Tropical Cyclone Informations is provided every 4 a.m. and 4 p.m. on the public weather forecast. So the next product is the Tropical Cyclone Advisory. So if there is a tropical cyclone within the TC domain, the one that I showed earlier, and is expected to enter the Philippine Area of Responsibility within 5 days, we will issue the Tropical Cyclone Advisory. So the contents of these products include information about the tropical cyclone, like maximum sustained winds, the gustiness, the movement, and the 5-day forecast position in a 24-hour interval. Also, we provide information on track and intensity outlook and the hazard that this system will bring effects to the land and coastal waters. So the initial issuance is anytime, and the succeeding issuances shall be made at 11 a.m. Next, before I discuss the next product, allow me first to discuss the tropical cyclone category we are using. So we have used this classification since 2015. First is the tropical depression category with less than 34 knots or 62 km per hour. Second is the tropical storm with 62 to 88 km per hour of sustained winds. Next is the severe tropical storm with 89 to 170 km per hour. And next is the typhoon category with 118 to 222 km per hour. The last one is the super typhoon category with more than 222 km per hour. So this one is the tropical cyclone warning for shipping. So this product is issued when there is a tropical cyclone that enters or develops within the Philippine area of responsibility. The initial issuance is in conjunction with the initial issuance of the severe weather bulletin, and the succeeding issuances shall be made at 5 a.m., 11 a.m., 5 p.m., and 11 p.m. So this product contains the analysis of the tropical cyclone position, the movement, the central pressure, the maximum winds, and the analysis of the tropical cyclone radius of 64 knots, 50 knots, and 30 knots in all quadrants, and also the forecast position and the forecast category. So next one is the severe weather bulletin alert. This product is issued when a tropical cyclone enters or develops within the Philippine area of responsibility and no tropical cyclone wind signal is in effect. So the initial issuance shall be made 3 hours after the standard observation time. And the succeeding issuances shall be made 11 a.m. and 11 p.m. Also, information such as track and intensity outlook, the hazards affecting the land and coastal waters, as well as the information on other systems that are being monitored are included in this product. So before I discuss the last product, let me introduce to you the tropical cyclone wind signals that we are using. So TCWS number 1, winds of 30 to 60 km per hour and a lead time of 36 hours with this corresponding impacts. Number 2, TCWS number 2 is 61 to 120 km per hour with a lead time of 24 hours. Number 3, 121 to 170 with a lead time of 18 hours. And TCWS number 4, 171 to 220 km per hour with a lead time of 12 hours. And the last one is TCWS number 5 with maximum winds of more than 220 km with the same lead time of 12 hours. So the last one is the severe weather bulletin warning. So same information you can find in the severe weather bulletin alert, but with additional information like areas with tropical cyclone wind signals and their impacts. So we issued this when a tropical cyclone enters or develops within the Philippine area of responsibility and the tropical cyclone wind signal is in effect. So the initial issuance shall be made 3 hours after the standard observation time, and the succeeding issuances shall be made at 5 a.m., 11 a.m., 5 p.m., and 11 p.m. And if the tropical cyclone is forecast to make a close approach within 100 km or to make landfall within 24 hours, we issue the warning every 3 hours. So this is the sample of our tropical cyclone forecast track and its probability cone. The cone is the possible forecast track of the tropical cyclone. So this is our forecast and warning dissemination flow. All the tropical cyclone advisories and warnings are sent to the Office of the President, Office of the Civil Defense, the Quad Media, and the PAGASA regional and field station, and to the general public. So the tropical cyclone warnings for shippings are sent to the navigators. Also, there's a pre-disaster risk assessment conducted at the Office of the Civil Defense. Here we assess the possible impacts of the hazard to the community and is used to determine the appropriate level of response action from the national government to the local government. Also, as a part of dissemination is we conduct press briefings and press conferences regularly. And this is our mode of communication also. We disseminate our forecast and warnings through Twitter, Facebook, and also do a live report and uploaded it in YouTube and also to our official website. And for our plans in this section, we plan to develop a ship route forecast, the first. And second, we plan to develop marine and forecast bulletin for high seas, and marine bulletin for coastal and inland areas. So this will refine our existing gale warning product. And lastly, a joint memorandum circular between PAGASA, Maritime Industry Authority, or the Marina, and the Philippine Coast Guard for the mandatory provision of meteorological data of the shipping vessels to PAGASA when they are inside our area of responsibility, because those observed data are very essential in our forecast. Thank you.
Okay, thank you very much, June. Sir June,
Hello.
thank you very much for this very comprehensive presentation about the marine meteorological products and services of PAGASA. So you have heard a lot from Mr. Galang about PAGASA's product services, particularly provision of tropical cyclone forecasts and warnings as part of their marine meteorological services here at PAGASA. So it's time to entertain more questions about Mr. Galang's presentation. So if you have clarifications, kung meron po kayong mga clarifications, mga tanong tungkol dito sa ating mga marine meteorological products and services ng PAGASA, so feel free to do so. Pwede pong i-unmute nyo ang microphone. So we encourage our stakeholders, so please ask questions directly to Mr. Galang. So maaari na po kayong magtanong sa ngayon. So anybody from the participants, please. Anybody from the participants? So I have some question, Sir June. Opo. So dun sa mga pinakita po nating mga forecast products and services, yung mga marine net services. So yung surface wave height, kasi dun there are some partners sa mga project-based partners natin. They require surface wave height forecast for the next 5 to 10 days, for example, kasi yun po yung ginagamit for aquaculture and aqua services, yung mga particularly the Bureau of Fisheries and Aquatic Resources and other yung mga fisher folks natin. So is there a possibility in the future that PAGASA will provide aside dun sa mga met products natin yung at least 10-day surface wave height forecast products that is readily applicable for our fisher folks? Is there a way po na yun ay ating mapoproduce in the future?
Hello? Dinig ba?
Yes, sir.
Hello. Hi. Regarding sa surface wave height na forecast, kasama rin sa mga plano natin na ibigay yan. Although slowly, iniisa-isa natin yung mga products na sa tingin natin makakatulong at makakapag-improve dito sa mga services natin sa marine. So, part din yan sa mga plans natin.
Opo. Okay, thank you. So, yun po yung usually na kinakailangan din ng mga marine services. Is there other questions? So may isang question po dito sa ating mga participants. So thank you for the presentation, Sir June. So how are these advisories usually communicated to small-scale fisheries? Is it still usually through the LGU? Or does PAGASA have projects exploring direct communication to the last mile in coastal communities? So yung mga small-scale fisher folks po natin.
Well, sa ngayon, through LGU pa rin, through GILG pa rin ang sending natin ng information. Aside from that, we also send yung information natin sa Office of the Civil Defense. Ang alam ko, nagsesend din sila hanggang sa pinaka end user talaga. So, doon sa tanong na kung merong project, exploring yung direct communication, sa ngayon, wala akong info. Pero hindi ko masasabing wala. Pero sa ngayon, wala akong info regarding dyan. So, pag nagkaroon akong info regarding dyan, babalikan na lang kita.
Okay, so may question pa po ditong dalawa, Sir June, if you need to entertain po. So dito, paano may nag-question po sa ating FB Live? Paano natin masisiguro na wala nang mangyayaring insidente tulad ng MV Princess of the Star?
So lahat naman sa ngayon, lahat ng warnings binibigay natin. Yung kasing insidente na ganun. Pag-accident kasi hindi natin napiprevent na mangyari yan. Pero lahat ginagawa ng PAGASA ng ahensya natin para makatulong na maiwasan yung mga ganitong incident. Marami na tayong product na nilalabas regarding sa marine services like gale warning, yung mga tropical cyclone advisories, weather forecast na at plano pa nating dagdagan yan kasama sa plans na binanggit natin kanina para mas makatulong pa, mas ma-improve pa yung marine services natin.
Okay, thank you very much, Sir June. So, yun po. So, actually, hindi lang po ang role ng PAGASA, yung pong mga ganitong mga issues. So, we need to get in touch with different government concerned agencies involved here. So, meron po pong question dito for Sir Galang. So, do we have wave gauges installed in our coastal or offshore water? Yung pong mga naka-install po nating mga monitoring observations along the coast.
So, yung mga wave gauges natin, ang alam ko, ang control din nasa PBOX. Although, dati may plano na makipag-coordinate dun sa para makapagtayo din tayo ng mga sariling wave gauges natin. At the same time, yung data nila may bibigay sa atin, tapos yung data natin si-share natin sa kanila para makuha natin lahat ng wave gauges, yung wave heights dito sa may coastal areas. Isang project na iniisip din natin.
Okay, so I think yun po yung mga questions na na-entertain natin from different participants, particularly yung mga nasa FB Live din po natin. So, I think dito po matatapos yung ating Q&A portion for Mr. June Galang. So, kung meron pa pong questions yung ating mga participants, so just email us. So, sa mga stakeholders natin, so we can reach out to you na i-send nyo lang po sa amin yung mga clarifications or concerns nyo, and then we could get back to you by sending those clarifications, questions, and comments sa ating mga naging speakers natin today. So I think it's time to turn you over to Dr. Servando for the certificates of appreciation and token appreciation to be given by to our speaker, Sir June Galang. Sir June, thank you very much po for your wonderful talk. And back to you, Doc Nats.
So back to the studio. Thank you, Miss Anna. So for the awarding again of the Certificate of Appreciation and Token, this will be given by Dr. Servando. Sir?
Once again, thank you very much, Mr. Juanito John Galang, for your presentation on PAGASA's marine meteorological products and services. One of the basic information and services that we are providing the public, particularly the maritime industry. And to express our gratitude for your support to this scientific forum, we are giving you the certificate of appreciation. And allow me to read this certificate for you. The Philippine Atmospheric, Geophysical, and Astronomical Services Administration, PAGASA, awards this certificate of appreciation to Juanito S. Galang in sincere appreciation and grateful recognition of his invaluable and unselfish support by sharing his expertise as resource speaker during the scientific forum linking Philippine climate and weather with tropical oceans, held on 23 March 2021, PAGASA Central Office, Philippines, via Zoom. Signed, Vicente B. Malano, a PhD administrator. And along this certificate of appreciation, we have prepared for you a simple token of appreciation, horse-shaped wooden handicraft made of kamagong. Kamagong is one of the hardest wood found in the Philippines. Again, thank you very much, Mr. Jun Galang.
So, thank you, sir. So we are now approaching the end of our activity. And to give us the closing remarks. But before that, let me remind you again, for the first time, to kindly answer the evaluation form, which can be accessed from the from the link. And please, we need those feedbacks for us to further improve similar forum or activity like this one. So going back, we are now approaching the end of our activity for today. No, not actually. We have a long day celebration. We actually have 3 days celebration for this World Meteorological Day. And for now, to give the closing remarks, we now give the stage or the floor to PAGASA's Deputy Administrator for Research and Development. Please welcome Dr. Esperanza Cayanan. Ma'am?
Thank you very much, Christy. Good morning, everyone. I believe everybody will agree that the scientific forum that we have today is a very successful one. It is really fortunate for us that we have great and expert resource speaker today. So the topics that we have are really relate to the theme linking climate and weather with tropical oceans. So these are delivered by our top caliber expert, internationally known. And so at this point, we would like to extend our sincere appreciations to all of them. First, we have Dr. Michael McFadden from National Oceanic and Atmospheric Administration, or NOAA, Dr. Yung O. Kwon of Woods Hole Oceanographic Institution, Dr. Vasila Thiao, again of NOAA, and of course, our very own Mr. Juanito Galang, our weather forecaster from the Weather Division. Likewise, we would also like to commend the organizing committee in making this event a very successful one. Of course, this committee is headed by our very own Dr. Nathaniel Servando as the overall chair, Mr. Daniel Suarez, the vice chair, and all the members of the organizing committee, especially to mention Ms. Ana Solis, who is with us this morning, and also Lorenzo Moron, and Mr. Michael Bala, and all the members who contributed for the success of this activity this morning. Thank you very much to everyone, and we hope you will stay tuned with the other activities regarding the celebration of the World Meteorological Day until tomorrow, wherein we have another forum, which is Meteorology for Science Enthusiasts. So, thank you very much once again. Magandang umaga po sa ating lahat.
Okay. Thank you, Ma'am SP. Thank you very much also to our speakers for today. Your contribution is highly appreciated. And for the participants who took time off from their busy schedules to be with us on this scientific forum, to the organizers and to all those who in one way or the other contributed to the success of this forum, maraming salamat po. And again, a reminder, please don't forget to answer the evaluation form which can be accessed from the link. We need this for your feedbacks for us to further improve our similar forum or activity. And to remind you also, stay tuned. Also, we have, after this one, for the press conference, so we have some announcements to make. So for those who are interested and to ask questions, please stand by after this one. Thank you very much.